example one is the easiest kind of word problem you get because they actually just give you the equation. So giving you the equation takes all of the fun out of the question and all of the work out of it. Well, we still have some work to do. So tides come in and out, and as they come in and out, the water is either deep or not as deep. And they have an equation that says the depth of the water is given by this equation. And we want to sketch the graph. So we're going to see this. Do we know the center line? Yes. Sometimes when I draw my X and Y axes, you know, I sort of do it in different places every time. I actually do some mental math before I draw my axes. What mental math do? I look at what my D value is, and I also look at my amplitude for max and min. Can you see that your D value is at 13.7, and you're going to go up and down 4.5? I don't need any negative numbers. So I set up my scale based on that. I do a little bit of mental math. So if you were thinking I just got lucky every time, that, oh, that fit nice, I'm actually thinking about it before. And then, because my D value is 13.7, I just pick. That looks like a nice place to have 13.7. I can draw a dotted line across there. That's my center line at 13.7. And then, if that's 13.7, 4.5 up and down would probably be about like that. So I try to somewhat do it to scale, but it doesn't have to be perfect. Up 4.5 will get me to 18.2. Down 4.5 will get me to 9.2. So I've done the D and the A values already. My period is always 2 pi divided by my B value, and my B value is 0.16 pi. Go to your calculator for this and divide it, and you'll get 12.5, and time is in hours. We can add a unit there if we want. So because this is a word problem, it's probably not bad to write that this is depth, and our unit is meters, and this is time, and our unit is hours. So if my period is 12.5, I go along here, I mark 12.5, and I divide it into 4 equal sections. Half of that would be 6.25, half of that, 3.125, and 3 of these would be 9.375. Real life questions, they don't care if the numbers aren't nice. So often what happens in real life questions are like, oh, you've got lots of decimals to work with. Now I'm going to draw my graph, the dotted line. It is a negative coast graph. Coast graphs, oh, there's no shift. So I could draw with a dotted line. Right? The dotted line would look like this. Started here, 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 back to center line, back to minimum. There's my dotted line. But then when I realize there's no shift, there's my actual graph. So we can sketch the graph easily. Now part B. This is a big ship. Bulk carrier, a big ship needs at least 14.5 meters of water to be able to be safe. How many hours can it be safe? So we're going to solve this in 2 different ways. One, to help prepare for those of you that are taking AP Calculus next year. We're going to look at how we can use our graphing calculator to quickly solve this. And then for all of you going to university after this year, where they don't let you use calculators very much, or just scientific calculators, we're going to look at how you would have to solve this if you just had a scientific calculator. Okay? But a graphing calculator solution first. We need to draw our blue graph. So the first thing I'm going to do is I'm going to go to my calculator and type the equation in. So I go to y equals for my graphs, and I'm going to have negative 4.5 cos bracket, oops, it already had a bracket, 0.16 pi. There's no t, so we use the x button. Close the bracket, plus 13.7. Now I have the right equation in there, but when I hit graph, probably yours looks like this. What just happened? Well, when you hit graph, you see a part of the graph. Technically, the graph that you see always goes from minus 10 to 10. So if I would think about where I get to see my graph, I'll just draw. 10 would be about here, to 10 there, to minus 10. This is the graph that my calculator is showing. Do you see why we only see the little bit? I want to see all of this graph. So it's really nice that I graphed it by hand, because then I can go to my window, what I see, and I can say, I just want to go from -1, but I want to go up to past 12.5. Maybe I want to go up to 15. And my y values, I don't need to go negatives. Maybe I'll go -1 so I can still see my x-axis. But my maximum was 18.2, so maybe I'll go up to 20. If I do that, it looks more like the graph that I drew. Also, things I can do on the window is I can change my scale, like 3.125 is what my ticky marks were. And maybe for my y's, I'll just go up by 5s. Then it draws my marks at different places. Now it's really starting to look like my graph. Okay? In y2, I can write 14.5. And it will draw a horizontal line at 14.5. If you've drawn both graphs at the same time, your calculator can quickly find out where they intersect. Everything for calculating stuff on graphs is above the trace button where it says calculate. So I go second trace, and I want to find out 5, where do they intersect? Push enter on your first graph, enter on your second graph, enter when it says guess, 9.02. I can go back to this, and I can go, this one's at 9.02. I need to also find this one. So I do the same thing, second, calculate, intersection. It will always find the intersection where your cursor is closest to. So if I do enter 3 times, it's going to find the same one. But if I use the arrow keys here and move my cursor, technically this would be enough. It's now closer to the other one. I feel like I want to go back. Push enter once now, enter twice, enter a third time on the guess, and 3.48, it finds the second. Whoa. There we go. 3.48. So, if you subtracted the 2, you'd be able to say that it is safe for about 5.5 hours. All right, 5.5, yeah, about. Right, from 3.48 to 9.02, just over 5 hours it would be safe. And then the boat needs to go out into the ocean while the tides, otherwise it's going to hit the bottom of that harbor. Okay? Now I'm going to show you the algebra, but I'm going to show it to you. Don't try to write it down. Just try to follow along. If you want to write it down later, it's on the video, but I will go way too fast if you try to write it down. So we're going to watch what you would have to do in university if you were solving this question. First of all, since the height is 14.5, you could plug in the 14.5 for d. Our goal is to solve for t. T right now is inside cos. You know how to solve cos equations. But first, let's get the cos by itself. So I'll move the 13.7 over, I'll divide by negative 4.5, and now I have the cos by itself. But you're used to solving questions that are like, I don't like all this stuff inside. It's so much easier if I just have cos theta. So we do that. We go, well, let's just temporarily make theta the inside. So my question looks easier. If you had this, cos theta equals this, you could solve. What would you need to do? It's not on your pie plate, obviously. You have to find a reference angle. How do we find a reference angle? We do cos inverse of the positive value. We get a reference angle. And then cos is negative, so we would find answers in quadrant 2 and quadrant 3. In quadrant 2, you do pi minus your reference angle. In quadrant 3, you do pi plus your reference angle. So we just figured out that theta was equal to these two things. But we wanted to solve for t, not for theta. What did we just temporarily do? We temporarily made theta this to make our life easier. Now we're going to have to go back and undo what we did to temporarily make our life easier. So substitute back. In quadrant 2, substitute this back in. And how would I get t by itself? I just divide, and there's our 3.48. Calculator was still a lot faster, wasn't it? Same thing in quadrant 3. Substitute it back in, and you get your 9.02. So based on both of those numbers, you get that 5.5 hours that it's safe for. So we could solve this with just a scientific calculator, and that's what would be expected in university. AP calculus, they'd expect you to do it with your graphing calculator, so you could do it quicker. Question?
So if we have this kind of question on the exam, maybe we solve it like this.
So you won't get this question on the exam for this amount, okay? This is probably, you might get a question like this if you were taking grade 12 applied math, because it's really graphing calculator. The amount of algebra that you have to do with the substitution in there, they'd be like, oh, too many people are going to make mistakes, so then they don't put it on the exam. However, they totally expect you to be able to do it easily once you get to university. So it's kind of like, well, maybe they should put it on the exam. And you will do lots of this kind of thinking in AP Calculus, where you have to do substitutions and know how things work. All right. So what is more typical? More typical to get a question like this. They tell you the information. Can you take the information of this Ferris wheel and draw a graph? If you can draw a graph, can you find its equation? So, first of all, I'm going to draw my Ferris wheel because I think that'll help me visualize what's happening. Here's my circle, spokes. What do I know about this? I know that the radius is 15, so I could draw my radius that way, but it's probably going to be more helpful if I draw my radius straight up and down. And then right beside this Ferris wheel, so let me draw my Ferris wheel. Actually, rotate it down just a little bit. And then right beside, I'm going to draw my x-axis and y-axis. So my Ferris wheel is like right there on the graph. Okay? Very smart that you get on above the ground. Ferris wheels that go into the ground are dangerous. Probably not that much fun. Okay, so we start at 1 meter. So we're like, yay, there's my first point on my graph. I am starting at 1 meter. can you see from this that you know the center has to be there, the maximum has to be there, and since we know the radius is 15, does it make sense? This will be at 16, up 15 from there. And the maximum up 15 again will be at 31. So this is how we use the radius to draw something on our graph. Now it takes 20 seconds, so I'll mark 20 seconds, to go all the way around so I know there's a second point. If it takes 20 seconds to go all the way around, where will you be at 10 seconds? The very top. And we could add 5 and 15. And that's where you would be in the middle. So we have our graph based on the situation. They told us the period, so we could draw that. We could divide it into 4 equal sections, and based on the information, you know where you would be. 0 seconds, right? Happy face guy. Just have to imagine a body this time, okay? Happy face guy there at 0. 5 seconds. You're going to be there. 10 seconds at the top. 15 seconds. 20 seconds. Back to where you began. So we show that on here. 5 seconds. Then 5 seconds there. Then 10 seconds up there. Smartboard used to be that. Okay. Now part B says, estimate the height after 22 seconds. Just says estimate. So as long as your answer is somewhat reasonable, you're going to be fine. 22 seconds. There'd be 25. If you agree that 25 would be back there again. 22 seconds. Probably there. Okay? If you said any reasonable number, you went straight across from that, you want to go 6 meters, 5 meters, any reasonable answer would be fine, because we're estimating. If we wanted to find it exactly, we'd probably have to either use our calculator to do that. And then we need an equation if we wanted to find our calculator. So, did it ask us equation in A? Did I miss it? It says find an equation. So we need to think about DAB C here. We've got the graph. Do we know our center line? Yes, 16. Do we know our amplitude? Yes, 15. We know that our period is 20. So our V value is going to be 2 pi over 20. And the C, I'm not going to write because it could change, depending on which one you would do. For graphs that start at a minimum, I would probably most often recommend a negative cos graph. Negative 15 cos bracket 2 pi over 20. X minus 0, you wouldn't have to write the 0, plus 16. That would probably be my first recommendation, because it starts at a minimum. But we could also pick a sine graph. Y equals 15, sine. Now I picked a positive sine graph. Where does sine start? In the middle going up. So my V value is still going to be 2 pi over 20. But now instead of x minus 0, I have x minus 5. Could we do a positive cos graph? Yes, that would be a minus 10. Could we do a negative sine graph? Yes, minus 15. So there's lots of possibilities for writing the equation. If you wanted to find out this exact number, what would you have to plug into the equation? And where? you wanted to find that exact value, you would plug in 22 for the x. So you can do that on your own time and check how close we were with 5. Were we accurate or were we way off? Estimate what time you will be 20 meters above the ground. Let's go back to our graph. 20 would be, I'll do it in orange. 20 looks like it's about there. There's you're at 20. There you would be at 20. What time? I don't know. Looks like at about 7. That would be an estimate. If you wanted to solve this exactly, you would have to go to your graphing calculator, draw this graph, draw the line of 20, and find out where they intersect. So that's how we could use our graphing calculator to find out exactly what it would be. Okay. We're going to leave this one for tomorrow, but I want you to start. There's 2 questions at the bottom of that page to try on your own. Try the Ferris wheel one or try the other one.